Okay, look, now we get to do the back. Yay! Write the two formulas for finding the sum of arithmetic sequence. These are both important to know. They have a little bit different usage. The first one is a lot cleaner, and I'm going to end up using that one pretty much the whole time. But I'll explain why the other one has some value. So we've got n times a sub 1 plus a sub n. Again, these are things he gave in the lecture if you look through the instruction book over 2. The other one, so this is n times a sub 1 plus a sub n over 2. Sometimes you'll see it as n over 2 parentheses a1 plus an. It's the same thing. It's just a matter of doing everything, then dividing by 2, or dividing by 2 and then multiplying it. It's all the same. Okay, the second way you can write this is n over 2. He did squiggly brackets somewhere in there. Please don't use squiggly brackets inside here. Use a bracket. 2a sub 1 plus n minus 1 times d. Boop, boop, boop. Okay, so if you notice, this is really a throwback, and you can see that formula we just did. So the a sub 1 times n minus 1 times d. This is the formula we use to find s of n. So to find a specific term, that's where this a sub n. So he oftentimes will use, when he wants to find a sub n for this formula, he uses the formula we just did on the previous page, just the a sub 1 plus n minus 1 times d. He uses this part to find a sub n. That's why these two are equal to one another, because the formula for a sub n is embedded into this other formula. Now, I will get to that in a minute. You can hear all my fun opinions. Okay, so there's our formulas, yippity skippity. We are going to find the sum of each of the following series. These are great fun. I feel really smart when I do them, so hopefully you feel smart as well. Just for fun, let's use green because yesterday was St. Patrick's Day. Okay, we need to find the sum of the following series. So just some things to remind you. Down here, this k value is called your index. A lot of times it's going to be an n. Sometimes it'll be a k. It could be any letter at once, to be quite honest. It's just whatever, whoever wrote the book is whatever letter they use. Okay, this is called the index. This is your n value. That's your final number of terms that you're going through. So that's what you're going to use for n anywhere you see n. This is the formula you're going to be using along the way. That's going to show us what our common difference is, things like that. And then the cool little sigma guy just means summation. So let's erase all that fun stuff. Okay, number 1, I'm going to start by using this formula up here. This is where I'm going to base my information off of. I'm going to make my pen smaller. So we're going to first, we need to know what a sub 1 is and a sub n is, so we can use the formula. This 6 up here is my n. So first we need to find a sub 1. That is the first term. So that means if we plug 1 in for k, that's where we're starting. If we plug 1 in for k, what is our answer going to be? Okay, and always your first term is whatever your k value starts at down here. So we're starting with a k value of 1 because we're keeping it simple. So a sub 1 would be 5 times 1, which is just 5. Then we need to find a sub n. This is where in the lecture and in the book and in the answer key, if he's using this formula, he will go back to this formula here. He will find a sub n using that formula, but you don't actually have to do that. You can use good logic and understanding of this formula. An is whatever this number is up here. So to find a sub n, you're going to plug that upper limit into your formula. So to find a sub n, we're going to do 5 times 6 because my n value is 6, and that gives me 30. If we were to use the a sub 1 plus n minus 1 times d, we'll get the same thing. We already found a sub 1 is 5. My n is 6, so 6 minus 1 would be 5 times d. The problem is we don't know what d is, so then we have to compute the first term and the second term. So we'd say, well, crap, now I don't know what d is, so the second term, a sub 2, would be 10. So from 5 at a sub 1 to 10 at a sub 2 is a change of 5. So that means my d value is 5. So 5 times 5 plus 5 times 5 would be 5 plus 25, which is 30. Or we could have just plugged it in like we did here. So yes, this works. And that uses the previous formula, but we're just gonna plug the n value in, this number up top, plug it into the formula, and that's going to tell us a sub n. Okay, so you can just skip those lines of the answer key. Okay, so now we know a sub 1, we know a sub n, we know what n is, our n is 6, we can use our formula. So we're going to say the summation of this is equal to n, which is 6, a1, which we computed to be 5, plus a sub n, which we computed to be 30, all of that divided by 2. This is equal to 6 times 35 divided by 2. I'm going to do this part first. 6 divided by 2 is 3. 3 times 35 is 105. And that's your final answer. So if you were to take the first 6 terms from K1 to K6 using the formula of 5K and add them all together, you would get 105. Okay, let's look at 17. Same idea. I'm going to keep using the same formula because it's a lot simpler and basic to use, and it uses the information given to you and the understanding of sigma. So a sub 1 is going to be negative 2 times 1, which is negative 2. A sub n is going to be negative 2 times 7, which is negative 14. Then we use our formula. The summation is equal to n, 7, times negative 2 plus negative 14 divided by 2. This would be 7 times negative 16 divided by 2. Again, I like to make my life easier. So negative 16 divided by 2 is negative 8. And I know that 7 times negative 8 is negative 56. Doop, doop, doop. You get your answer there. Okay, you're going to run through that the same way. I'm going to quickly go through 18 just because it's got more parts, but it's the same thing. A sub 1, plugging in 1. 3 times 1 plus 1 is 4. A sub n. I don't know if you can hear my children screaming. They're supposed to be reading. It doesn't sound like they're reading out there. So I hope you guys obey your parents better than mine obey me. A sub n, we're going to plug in 5. 3 times 5 plus 1 is 16. So then we're going to say our summation is equal to 5, which is my n. 4 plus 16 divided by 2. 4 plus 16 is 20. 20 divided by 2 is 10. 10 times 5 is 50, or you could have done 20 times 5 is 100 divided by 2 is 50. Whatever makes your brain happy. Huzzah! Then we go back to these wonderful review of happy little logarithms. Let's get a happy purple color. Okay, these first two want you to rewrite the logs as exponents and the exponents as logs. This is just your little swirly, just rewrite it swirled. So you're going to say 17 squared equals 289. That's all you have to do. Okay, 9 is going to be your base, and then we swirl from there. So you'll say log base 9, whatever the base of the exponent is the base of your log, of 3 equals 1/2. Okay, so those ones you're just rewriting it, doing the swirly around. Not a lot of mental pain there. Solving for the variable, that's when we're going to get a equals x equals something of the sorts. On this one, we're going to go ahead and start by doing the swirl because I can't do much with a log sitting there. So I'm going to say a to the third power equals 27 over 64. If I want to figure out what just plain a is, then I'm going to take the cube root of both sides. When we take the cube root of a fraction, that is equal to the cube root of the top divided by the cube root of the bottom. The cube root is what times itself gives you that number. 3 times 3 times 3 is 27. Cube root of 27 is 3. 4 times 4 times 4 is 64. So my answer is 3/4. Okay, 22 is the extra fun one, and I did not give myself much space, so we're gonna We're going to try our best, everybody. We're going to try our best. Here we go. We are going to start by, when you have a log minus a log, you can divide their insides. Remember that minus in log land means to divide their insides. Okay, so what we're going to do is we're going to condense this into one logarithm. We're going to say log base 15 of x squared plus 2x minus 63 over x plus 9 equals 1, because that's what it says over there. Good news for us, we're real smart at this point, and we should think, oh, I see a bunch of x squareds and stuff. I'm probably going to need to factor. That says 15, by the way. So we're going to factor the top. Use your best knowledge to figure out that probably one of those factors is going to be the same as the bottom, which it is, because 9 times negative 7 is negative 63, and 9 plus negative 7 is positive 2. So then we've got x plus 9 on the bottom. Oh, y'all, this is getting ugly. Pretend. Our x plus 9s cancel out. Ah! So we're going to write real prettier over here. We've got log, what we're left with is log base 15 of x minus 7 is equal to 1. We can now do our swirl. We've got one log. Once you have one log, you can rewrite into swirly form. So we'll say 15 to the first power equals x minus 7. 15 to the first power is just 15. So to get x by itself, we'll add 7 to both sides. So x is equal to 22. Boop, 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 boop. Awesome. Okay, let me flip through. I just thought of something while I was saying all of these to you guys. I will flip through. I've got one more that I will probably add on, so I might end up throwing a third video up here just to show you a weird case scenario, but I think this one's getting too long, and so while I check to make sure the one I'm thinking is weird, I'm going to end